let us take it as a question itself that let's say there are two sorted arrays. This is very important. The two arrays that you have, both of them are sorted, and now I want to merge them into a single sorted array. So two sorted arrays are given and I eventually want to merge them into a single sorted array. So the question technically means something like this, that let's say array 1 is given to you, which is sorted. Array 2 is given to you, which is also sorted. Now I want to create another array 3, okay, where these elements should also be there and these elements should also be there. So 4 plus 3, 7 elements should be there, but they should be present in a sorted manner. So how will they be present here? They will be present here like 2, 5, 7, 9, 11, 15 and 20. This is how they will be present. Okay, so one thing is quite obvious, that if the two arrays which are in my input, if the first array 1 is of size m and second array 2 is of size n, then whatever is my output array, what should be its size? Its size must be m plus n, right? And all the elements should be present in the sorted format. Okay, tell me one thing. Let's say you did not know how to solve this problem. Okay, then how would you solve it? What is the most intuitive approach that strikes your head? Yeah, so the easiest solution could be that I can, declare array 3 of size m plus n, and I can copy all the elements from here, simply copy them as they are, okay, and I can simply copy these also as they are after this, and after this copy step I can perform the sorting of this. Okay, so let's talk about this basic solution. Can somebody talk about the time complexity of this basic solution? The sizes are m and n, so answer me clearly. Yeah, so most of you are answering it correctly. So how much time will the copy step take? Since you are copying all the elements from array 1 and array 2 into array 3, and copying one element is like order 1 task, so order m plus n time will be required for copying them. And now when you sort this array of size m plus n, then what is the complexity of sorting? It is x log x. Okay, in the best case, if you are using the most well known and the most efficient sorting algorithm, so that is x log x, where the size of array is x. So even if, let's say, then you sort it using merge sort or heap sort or quick sort, whatever you say, the time complexity of that sort step will be m plus n log m plus n. So effectively this would be your time complexity, right? But let me ask you a question. This approach would have been applicable even if array 1 and array 2 were not sorted, isn't it? Right? Even if array 1 and array 2 were not sorted, this approach would quite have been applicable. So can you exploit the fact that they are sorted? Actually you can, and that is the reason you can perform this merge process in a time which is lesser than m plus n log m plus n. Okay, yeah, here we are not exploiting, correct, but now let us see if we can exploit. The answer is we can exploit. And what is the basic intuition behind that we are all going to learn. So the basic intuition is, if somebody gives you such kind of array 1 and array 2 such that both of them are sorted, can you tell me what will be the smallest element? Can you tell me for sure what will be the smallest element, irrespective of what are the contents of array 1 and what are the contents of array 2? Yes, very good. So minimum element will be either this or this, isn't it? So minimum element will be, either the first element of array 1 or the first element of array 2, right? So finding the first element of my resultant array is an order 1 thing, because all I have to do is I have to compute min of array 1 0 and array 2 0, correct? right? This is how I can very easily compute my first element. Okay, but now let's say once you have computed your first element in the output, which happens to be 2, okay, so you can easily position this 2 over here. After this, what will you do? After this, what will you do? Can you tell me what will be your second element now? What will be your second element of the resultant array? Yeah, so you are saying 5, and why you are saying 5 is because the contenders for this 0th element were this and this, and once you found out that this is your smallest element, okay, so next thing would either be this, because it will definitely not be something which is greater than this, right? Because whatever will come over here, that will be something which is just greater than 2, okay, and just greater than 2 will either be 7 or something present over here, because all of these are greater than 7 and they can't afford to come before 7, okay. So in that case, what will I do? That I'll simply increment this pointer over here and let this pointer remain wherever it is. So this way what is happening, that wherever my pointer is pointing, let's say this is pointing here and this is pointing here, then the next contender over here is min of this and this. So this is the most important point over here, that I manipulate my pointers, I manipulate my these indices which are being used as pointers in such a way that at any point of time, whatever is the min of the elements being pointed by them, that deserves to be the next element, okay. And this is only happening because the two arrays are sorted. Just because they are sorted, I could easily say that, hey, whatever will come after 2, that will either be 7, that can never be greater than 7. Why? Because this is sorted. So I am exploiting this particular information, and that is the reason wherever my 2 pointers are, either of them, whichever is minimum, would be my next element of my output array, right? So this is how you can go on and on. Again, if you take a look over here, so let's say this pointer is here and this pointer is here. So your next contender would be min of this and this. The minimum is 5, so now 5 will come over here. So the moment an element is gone, so you will increment this pointer. So if this pointer is here, that means all of them have been placed at their deserving locations, okay. Now next contender is this and this. The smaller one is 7, so 7 comes in over here, and then you increment the pointer for 7. So you see, whatever is from 0 to, let's say this index is I, so whatever is from 0 to I minus 1 and whatever is from 0 to j minus 1, they all have been positioned in a sorted manner, okay. And now my task is to solve for the part from I to n minus 1 and I to m minus 1 and j to n minus 1, right? And that I can do how I had done for previously, okay. So I'll compare this and this. So again, you compare 9 and 15, 9 is smaller, so 9 comes here, and this pointer comes here. Now you compare 11 and 15, the smaller one is 11, 11 comes here. Wherever the 2 pointers are pointing to, okay, so whatever is the minimum of those 2 elements, that deserves to be your next element, right? And you basically increment that pointer which was pointing to the smaller element. This is how you go on and on and on, right? Okay, so this is what I did. So eventually what would happen is that, let's say this is here and this is here. So out of 11 and 15, smaller one is 11. So you positioned 11 over here and then you incremented this pointer. So this came over here now. At this point of time, what would you do? At this point of time, you have got no more elements left in array 1, but you have got many elements left in array 2. So can somebody tell me what would you do? Yeah, so somebody is saying break, but you also have to be able to position these elements at their respective slots, right? So what would you do? Yeah, can I simply append them as they are? The answer is yes. And why I can append them as they are? Listen to the logic. Logic is because the reason they are left over is because all of them are greater than all of these. That is the reason they are left, right? So they will definitely come after all of those, and also they are sorted in themselves. So it is as good as just copying them sequentially as per their sequence. So that is how you can very easily get your job done. So let us try to understand its time complexity. Can somebody talk about the time complexity? How much would it be? Order m plus n. Why order m plus n? Because if you see clearly over here, what is happening? Any element is being touched how many times? So, or let's not think like that, think of it in this way. In every step, in every iteration, you get rid of how many elements? One element, right? So after m plus n steps, you would have got rid of all the m plus n elements. That's it, as easy as that. Okay, so that way I can say that the time complexity is order m plus n. And how about the space complexity? Am I using any extra space over here? Yes, I am using, and that is m plus n. So this thing is important to understand. Just because I have this extra array of size m plus n, that is the reason these placements were very easy for me to make, right? Otherwise they would not have been so easy for me to make. So what I can do is, let's say this was my array 1 and this was my array 2. So I was here and j was here. Okay, so what I can do is I'll initialize my I to 0 and j to 0, and now I'll write as long as I is smaller than m, okay, as long as I doesn't reach the end and j is smaller than n, what will I do? I'll compare array I and array j, and whatever is smaller of them, that will be placed in array 3. Okay, now I have to keep a track of the index of array 3 where I am supposed to place the next element. What I mean by that is, let's say at any point of time I was here and j was here. So I need to figure out the minimum and I need to place them at some particular index over here. So how can I track this index in array 3 where I am supposed to place the next element? Can I do that by having a separate variable k, separate index k, which tracks how many elements have been placed? Yeah, I can do that. You can do pushback also if you're using vector, but if you're using arrays, you might want to do just this. Yeah, great. So you can take k equals to 0 for that purpose. And now what you can do is, if array 1 I is smaller than equals to array 2 j, in this case what would you want to do? You would want to place array I over here. So you would say array 3 of what? K plus plus equals to array 1 of I plus plus. So this does three things at a time. It positions that element at its corresponding place and increments this pointer and increments that pointer also. So all of those are happening in just one line. Okay, cool. Otherwise what you have done? Otherwise you would have placed this element at kth slot. So you would have said array 3 of k plus plus equals to array 2 of j plus plus in this case. Okay, so is just this much of code enough? No. Why is it not enough? Because of the kind of termination condition that it has. It will terminate the moment one of the arrays becomes empty. Okay, and I know that it can very well happen that one array became empty and the other is still not empty, as I had shown you before. Are you getting me on that? Yeah. So in that case what you have to do, you have to copy the remaining elements into the array 3. So how can you do that? Now tell me one thing. Yes, can you tell for surety that let's say this loop is broken, then without making any check, without making any test, can you just tell vocally whether this got over or this got over? Can you say that? No. For that you will have to check. But is it guaranteed that only one of them would have been over and the other would have been partially left? Is it guaranteed or not? Yes. Yes. It can never happen. It can never happen that both of them are still not over. One of them would have got over for sure, right? Why? Because of this condition. Because this while loop, this for loop broke either because of this becoming true or because of this becoming true. Both can't become true at the same time, because at a time only one pointer is moving and the other is stationary, right? Cool. So as a last step, what would I do to copy back the elements from the remaining array? I would simply do something like this. For I smaller than m, that's it, and array 3 of C++ equals to array1 of I++. That's it. So what will it do? If it sees that array1 is over, if it sees that array1 is still not over, so it will run only if I is smaller than m. That denotes that the array1 was not over. Then it will copy back their elements to array3, right? And then I'll write another loop, j is smaller than m, and I'll write array3 of, this is k, array3 of k++ equals to array2 of j++. So either this loop would run or this loop would run. After this is completed, either this loop would run or this loop would run, and the elements would be copied back. Okay? Is it clear to everyone? How many of you understood this? Just say yes, those of you got this. Right? So this is how it works, and total number of operations that happened over here was m plus n operations. Okay. If you guys take a clear look at the number of comparisons, because see, what is happening over here effectively is a comparison only. What is happening over here is a comparison only. You compare an element of array 1 with an element of array 2, and then you decide which one is smaller, and then you put that in the another array. Okay, so the first step is the compare step. First step is the compare step, and then comes copy step. And then at times it can happen that some of the elements over here are left, or some of the elements over here are left. For them there is no comparison, for them there is just copy step. Okay, but number of iterations over here will be much lesser than number of iterations over here. Does everyone agree to that? Yes, no? Because very few elements would be left in most of the cases. Okay, yeah, at times it can happen where one array is very large and the other is very small, and it has very large element at index 0 itself. There so many iterations will happen in this step, but let's just ignore those cases for now. Let us just try to understand that the number of comparisons which again happen over here is something which is like order of m plus n only, right? And if you are concerned about number of comparisons plus number of copy steps, all those that have happened, that is again order of m plus n. That is exactly m plus n.